Okay, welcome. Now let us try to look at this question, which is not far from what we have been doing in our last lesson. The question says, a hollow right circular cone has base radius 4 meters and vertical height of 20 meters. It is held upside down with its axis vertical. It contains water which is being added at a constant rate of Ds per minute, and which leaks away through a small hole in the vertex at a constant rate of Ds. That is 2 cubic meters. At what rate is the depth of water changing when the depth is 12 meters? Now, dear learners, this is not far from what we look at in the time. But let us first try to illustrate this cone and see what goes on. Now, if I look at this cone in this way, let's have this cone like that, and it is vertical downward. So this would be, let's say, slanting height. Would be its slanting height, right? So the radius of the cone would be like that. Remember, this would be right angle. Right angle would be here at that point. Okay. Now, radius is it? The radius is 4 meters. And this height, the vertical height, we are told it is 20 meters. 20 meters. So if I may draw it, this height is 20 meters. Now, let us now assume that this water, which is being poured, is at this level. Okay? Now, it takes the radius of that to be r, and let the height be h, which I don't know. Now, remember that this water is being added and it is leaking out at the same time, coming out. Right? Now, when this height of the water changes, even the radius of the water also changes. At the same time, even the volume of the water changes. Now, that means we're going to have 3 variables. That is R and H and even the volume. Which in this case may not be easy to add all of them at the same time. Now, can I convert R in terms of H or otherwise? But at the basic, convert R in terms of H because we are talking about the depth, which is H. So H must be there, not R. So can we try to use this similarity of finger now? Looking at this triangle. We shall find that this height over this height, which is H, out of 20, equal to this radius over that radius, which is R out of 4. Right? Now, can I make R a subject by saying this is 4H is equal to 20R? Right? Making R become 4H out of 20. Making R become H over 5. That is radius of this water surface at a time t as it is being added and also leaks away. Right? Now, what is the volume of that water? Volume of the water, as you are aware, it also takes up the shape of the cone. It's going to be now that pi r squared h, which gives me now a third pi, r is now h, out of 5, like square times h, which gives me pi out of h cubed over over 75. Hope it's true. Because 5 squared give me 25. 25 times 3, 75. This is going to be water V. Now, what am I looking for? I'm looking for the height of water at the time T. But can we now find the rate of change of volume? Remember that water is being added at this rate and is leaking away at this rate. Therefore, my dV by dt would be 1.5 minus 2. Okay? Which gives me negative 0.5 cubic meter per minute. Now, what does it mean? It means the volume of the water is decreasing, which I think is correct. Because the rate at which it is being added is less than the rate at which it is not going out. That means the volume is falling, which gives me this negative here. That's the rate of change of volume. Now, what am I looking for? I'm looking for the H by dt. Now, remember, I now have the V dt. Can I get the V dh from here? Is it possible? Now, the V dh. Remember, my V was given to be pi h cubed over 75. Therefore, the V by the h would be 3 pi h squared out of 75, which I think comes to pi h squared over 25. Yes, we go by this, then 25. Right? So this is the VDH. I now know the VDT. What am I looking for? The HDT. Right? Now, by chain rule, can I combine this? Can I combine the VDH, the VDT, and the HDT? Possible. I will say the V by the T is equals to the V by the H times the H by the T. Is this chain rule appropriate? Yes, it's appropriate. Okay? It's appropriate here. Meaning now, but do I know the VDT? Yes, I know the VDT. So which will give me now negative 0.5 is equals to the VDH. The VDH, this is pi h squared out of 25 times now the HDT, which I'm looking for. Okay? So can I get now the HDT? So making the HDT equal to what? Can multiply this by that and divide by that. This is the 25 times negative 0.5, then the whole thing over pi h squared, that is the HDT. But of course, we will be told when the depth is 12, meaning I would say the h by the t give me 25 times negative 0.5 out of pi into 12 squared. Right? Which if you simplify, you get our answer in meter per minute. That is the HDT. So that's how this number can be done. Thank you.